In today's note, we are going to look at order of operations. So this may be a little bit of a review, but we're just going to go over it because this concept is important once we get into our other units, because it is kind of the basis or one of the basics of math in terms of solving problems. So a problem like 20 times 3 plus 15 divided by 5 can have several different answers depending on which order you do the calculations. So you may have seen questions like this. Sometimes they pop up on the internet or on Facebook, and it's kind of like, what answer do you get? And you look in the comments and you see people have multiple answers. So the main thing that people are getting multiple answers is because they're doing them in different orders. But to avoid this problem, mathematicians have agreed on an order of operations. So while you may have different answers, there is technically only one answer that is correct based on this order of operations. And the acronym BEDMAS is used to help us remember what order we must do the operations in. And the way it works is we have first brackets, then exponents, then multiplication or multiplying or dividing. So we do that whichever one comes first. So if multiplication comes first, we do that. If dividing comes first, we do that. And then lastly, we have addition or subtraction, or adding or subtracting. So again, whichever one comes first, that's the one we have to do. So again, hopefully this is a little bit of review, but if not, we're going to go through a couple examples that looks at different scenarios where our order of operations come into play. So the first one, in example 1, we have negative 8 plus 2 times negative 3 squared divided by negative 9. So what we're going to do is first start with our b. Do we have any brackets? And we do. So we have a set of brackets here at the very beginning. So I'm going to simplify that first. So negative 8 plus 2 is negative 6. And even though we see brackets throughout in the negative 3 and the negative 9, there's nothing inside those brackets that we can actually solve or simplify, so we're just going to leave them as they are. From there, we move on to our exponents, which we do see an exponent here, an exponent of 2. So that means when we go through, we can do this exponent. So negative 3 squared, or negative 3 times negative 3, is 9, divided by negative 9. And now we come down to multiplication or division, and we do see both. So in this case, we have to do whichever one comes first. And by first, we mean whichever one is at the beginning or on the left side. Right? If you think of reading a book, you read from left to right. So in this case, the multiplying comes first. So negative 6 times 9 is negative 54. And then we have divided by negative 9. And now we only have one operation left, which is division. So we can just do that operation, and we get 6 as our final answer. So in the end, this expression equals 6. Moving on to example 2. Again, same idea. Go through BEDMAS. Right? So start with brackets. We don't have any brackets in this case. So then exponents, which we don't have either. And then finally, next, multiplication or division, in which case we have multiples of those. So 4 plus, and then we have 2 times negative 6. So I'm going to do that first, which is negative 12. And then minus. And then I have another division here, which I can do this as well right after the first one because I'm doing it second. So 20 divided by 5 is 4. Next, I'm going to do some addition or subtraction, right, based off of BEDMAS. And the first one we see is addition. So I'm going to do 4 plus negative 12, so negative 8, and then minus 4. And now there's only one operation left, which is subtraction. So in the end, I get negative 12. Moving on to example 3. So example 3 looks a little bit different because it looks like a very complex fraction. Right? I have 30 divided by negative 5 all over negative 2 squared times 3. So when you see something like this with different operations or multiple operations in the numerator or the top, and multiple operations in the denominator or bottom, what you want to do is treat just the top part as a set of brackets and the bottom part as a set of brackets as well. So when you see a fraction like this, you want to simplify the top and the bottom first by assuming there are brackets around all of that. So I can simplify the top. I can solve that bracket. So 30 divided by -5 is -6, all divided by, and now in the bottom bracket, there's something first that I have to simplify, right? So I'm going to do the exponent inside the brackets. So -2 squared is 4, and then times 3. So once we go inside the brackets, if there's multiple operations, you go back to BEDMAS again. So that's why we did the exponents first inside this bottom bracket. Next, again, I still haven't simplified the bottom, so I'm still going to simplify that first. So 4 times 3, which is 12. And then finally, there's one last operation, right? Remember, if it's a fraction, it means divide. So -6 divided by 12 is -1/2, or -0.5. So even though this one's a little different, there's only one thing we just need to keep in mind. You can put a little note if you want. So you're going to put brackets around the numerator and around denominator. Right, so you're going to put those brackets around the numerator and around the denominator and treat them separately first. So moving on to our last example, example number 4. Again, we can see that we're dealing with a fraction again. So we have multiple things on top and multiple things on the bottom. So again, I'm going to put these brackets in. So I'm going to simplify or go through the top first and the bottom, or go through the top and the bottom separately, and before I do my final division. So in that top bracket, the first thing we can see brackets inside of brackets. So which one do you start with, right? But the thing is, when you have brackets inside of brackets, you start with the innermost brackets. Which in this case is the ones that I just highlighted. So when we go through, we're going to do 22, we're going to leave that, and then 14 minus, we have 12 divided by 6, which is 2. So that's what we're going to simplify next. On the bottom, because we're treating the bottom separately, we can simplify the 3 to the power of 3. So 3 times 3 times 3, which is 27, and then minus 5. Now again, going back to the top and treating the top separately, I'm going to treat my brackets, so it's going to be 22 times 12. And then the bottom I can simplify, so 27 divided by 5, which is 22. And then from there, now I can simplify the top. So I can do 22 times 12. Get 264, and then divided by 22, which in the end brings me back to 12. So in the end, 12 is my final answer. So after going through all of that, I should get 12 as my final answer. So again, multiple examples here, right? A few notes for depending on the scenarios that we come across. But the main idea is follow BEDMAS when you're going through when you have multiple operations. And if you follow that, you should get the same answer as everyone else. If you don't follow it, then there's chances are that you may get a different and incorrect answer.